Hello everyone. Today we are going to discuss one of the important chapters of plus two, that is function. Okay. Basically in this segment we will discuss definition of function and its type. Okay. So let us see here. First we will see definition of function. Definition of function. Definition of function. So now you tell me what is function. How can you define the function? Okay. So see, function is basically what? Function, it is just like a machine. Function, it is just like a machine. Means what? If you put input in the machine, then you will get some output, right? So let us see. Through diagram, we will try to understand. This is, let's say, machine. Okay. In this machine, if you put input, if you put input, if you give input, then you will get some output. You will get some output. Getting it? Means, let's say one example I am taking. Let's say this is juicer. Okay. By this example, you will understand it very well. Let's say this is juicer. In this juicer, if you put input, so what kind of input you can put in the juicer? Fruits, right? So fruits. Okay. If you put, then what you will get? You will get some output. As an output, what you will get? Juice you will get. Definitely you will get, right? So means what? Function, it behaves like machine. Means if you put input, then you will get some output. Means this is what you can say also, that this is practical definition of function also. Mathematical definition we will also discuss. Okay. So this is practical definition we can say. Getting it? So let's say one example I am taking. This is root x. This is one function root x. In this machine, what all value can be put? What all value can be put? So as we know that this is root, so we can put 0 and only positive value, right? 0 and positive value. So definitely we will get some output. Definitely we will get some output, right? And you can also ask, okay, this is, let's say, machine. Okay, this is, let's say, machine. In this machine, if you put, instead of putting fruits, if you put wood, then what will happen? Yeah, definitely machine will get broken. Why? Because every machine has their own efficiency, right? So it is not that whatever you want you put and you will get some output. No, if you have to get proper output, then you will have to put some specific input. Getting is, then after you can get that. So this is how we can define the function practically. And not only that, this is how you can also relate with our daily life. Getting this? Okay. So now we will see it's a mathematical definition. Now we will see it's a mathematical definition. So let us see here. Mathematical definition. Every element of A, every element of A, every element of A must have one and only one image in B. One image in B. What it means? See here. It is saying that every element of A, every element of A, let's say one, this is set of A element right now, and this is, let's say, a set of B element. Okay. It is saying that every element of A must have one and only one image in B. So these are the element of set A, 1, 2, 3. Then after, these are the set of element B. Okay. So see here, one mapped with A, two mapped with B, and three mapped with C. Getting it? So you can see definition. Every element of A must have one and only one image in B. Means one has one image, two has one image, and three has also one image. Okay, so this is what? This is function. So you can say that this is what? Function. Okay, so another example I am giving you, and you have to tell me that is it function or not. Okay, so let us say this is a set of A element and this is set of element B. Okay, so one, one, two, three. Okay, and here A, B, C, D. Here one has two image. You can see very clearly. One has two image. Okay, and two has one image, and three has one image. So can we say that this is function? Absolutely not. This is not function. Why? Because definition of function says that every element of A must have one and only one image in B. But you can see very clearly that one has two images in B. So this is not possible. This is the infringement of definition, you can say, right? So we cannot say that this is function. So this is not a function. Getting it? Right? So what we can say? What we can say? All element of A, all element of A should be mapped. All element of A should be mapped. Okay? Then you can say that this is a function. Otherwise, we cannot see. Getting this? Okay. Now you see. One important thing I am telling you. See here. You can write it as a note. Okay. If converging rays, try to understand. If converging rays, if converging rays are there, converging rays are there, then you can say this is function. Then you can say that this is function. Converging rays like this. Understood? This is converging rays. Okay. And diverging rays is not a function. Diverging rays. Diverging rays. Diverging rays is what? Like this. This is diverging rays. Understood? This is not a function. Not a function. Hope it is clear to everyone. Right? Okay. Now we will discuss domain, codomain, and range. So let's see here. Domain, codomain, and range. So see here, let us say this is element A, set of element A, let's say A, B, C, and D. Okay, these are the element of set A. And this is set of element B. This is set of element B. P, Q, R, S. Is it clear? Okay. First, we are going to find the domain. First, we are going to find the domain. Getting this? See here. A, let's say A mapped with P, then after B mapped with Q, then after C mapped with R, okay, and D also mapped with R. Okay, this is the example of function. Okay, and we will understand what is domain, what is codomain, and what is range. See here. So domain, and also that function is defined from A to B. You can write like this. Function is defined from A to B. Understood? Function is defined from A to B. Okay. So you tell me that what is the domain? See here. Function is defined from where to where? Function is defined from A to B, right? So this first element of set A, means element of set A. This is what? This is domain. Means what we can say, this is what? Domain. This is what? Domain. Getting this? And B, right? That is codomain. B is what? Codomain. Okay. And mapped elements are called range. Understood? So see here. So what will be the domain here? A, B, C, and D. These elements means all the element of set A is called domain. Okay. Now we'll discuss codomain. So what is the codomain? Codomain. Codomain. Set of element B. Set of all the element of set B. Understood? All the element of set B is codomain. So what we can write? P, Q, R, S. These are codomain. Okay. And what is range? What is range? What I said, mapped elements. Mapped elements are called range. So you can see very clearly that A mapped with what? P. Okay. B mapped with Q, and C mapped with R, and D mapped with R. So which all are mapped? Which all elements are mapped? So clearly you can see P, Q, R. Understood? So our range will be what? Range is P, Q, R. Understood? What is the domain? What is codomain? And what is range? See, again, I am telling, I am just repeating it. Set A, all the element of set A is domain. Whatever elements are there, that will be domain. Okay. Then after, set of element B will be codomain. Okay. Then after range, all mapped element in set B, only mapped element in set B will be what? Will be range. Understood? So hope it is clear to everyone what is domain, codomain, and range. Okay. Now we will discuss. Now we will discuss types of function. Okay. Types of function. See here. Type of function. First type is one function. All of you, make sure you are paying attention. One function. So see, what is one function? What is one function? And one more thing, one function is also called injective function. One function is also called injective function. In some of the books, you can see that it is written simply injective. So you have to understand that one function is only injective function. Understood? One function is called also injective function. Injective function. Okay. So see here. Let's say A, right? Element of set A and B. So one function means one mapping. Okay, one mapping. Let's say element. Let me write A, B, C, and D. These are the element of set A, and E, F, G, H, I. These are the element of set B. Okay, it is saying injective means one. So one mapping. A mapped with E, B mapped with F, C mapped with G, then after D mapped with H. That's it. That is called one function. Okay. And by mistake, if you are saying that B is also mapped with E, that will be the wrong. Then that is not, that will be the function, but not one function. Okay. One function definition is one mapping. A mapped with E, B mapped with F, C mapped with G, and D mapped with H. That is what? That is one function. So see, we will understand here through arrow diagram. We will try to understand. One example I am giving you. See here. Y is equals to fx. Okay. X plus 1 means one function I have taken. For example. Okay. So x belongs to A. Okay. X belongs to A and fx belongs to B. Getting it? Okay. So A set is given 1, 2, 3, 4. These are the element in the set A. Then after set B, These are the element of set B. Okay, so now you have to draw. Now you have to draw this arrow diagram. So how we can draw? See here. Let's say this is set A. Okay, so you can draw like this: 1, 2, 3, 4. Then after, this is the set of element B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let me, yeah. Okay, so this is element A, and this is set of element A, and this is set of element B. Okay, so what I am saying, if you put the value of x is 1, output you will get what? 2. You put here. If you put x 1, then what you will get? What will be the value of B? B is nothing but what? B is nothing but value of the function. Means if you put 1, then you will get 2, like this, right? Means A mapped with 2. Getting this? If you put 2 in the function, in this function, right, then you will get what? 3, right? Then after, if you put 3, then you will get 4. 4, then you will get 5. So see here, this is what? 1 1 mapping, right? So you can say that this is 1 1 function. Getting this? Okay. So now what we are going to discuss, when we have, a small sets, when we have a small sets, in that case, we can draw arrow diagram, and we can show that this is 1 1 function. But if we have, big set, that, we can say that function is defined from natural number to natural number, right? And function is defined from real number to real number, right? But it is, little difficult to draw arrow diagram. In that case, how we can show that this is 1 1 function? So for that, one method we will discuss. So let's see here. Let x and y, I am assuming it, simply I assumed that let x and y be two arbitrary element, be two arbitrary element. Two arbitrary element. Okay, so what we have to do, put fx is equals to f of y. Okay, fx is equals to fy, means you have to put x in the function and you have to put y in the function. Okay, if you get, all of you just listen to me, if we get, what we will get, if we get x is equals to y, if we get x is equals to y, then we can say, that this is 1 1 function. Okay, then we can say that this is what, then we can say, we can say we can say that, this is 1 1 function. Hope it is clear, right? Means what we have to do, if just we have to assume x and y two arbitrary element. Okay, then after you have to put fx, then after fy. If you get x is equals to y, then you can say that this is 1 1 function. So see here, one example we will do. By that, our concept will be cleared. Okay, so let us say this is function. Function is what? X cube plus 7. Okay, x cube plus 7, and function is defined from, real number to real number. Just you imagine, this is, big, right? This is big set, this is real number, means domain is also real number, and codomain is also real number. Getting this? So what we will do, simply we will assume that solution, let x and y, be two arbitrary element, two arbitrary element, that is x and y. Okay, then what we have to do, such that fx is equals to fy, right? Now fx is equals to fy, then what we have to do, this x you put in the function, okay, and y you put in the function. Okay, then what we will get? X cube plus 7 is equals to what? Y cube plus 7. Getting this? Simply I have put y in the function, that's it. Okay. So you can see 7 7 gets cancelled, then after we are getting x cube is equals to y cube. Okay, so what we can write? We can write x is equals to y. So we have got finally x is equals to y. Then we can say that yes, f is 1 function. Understood? Then we can say that this f is 1 function. Clear? So this is how you can explain 1 function, by arrow diagram and by this. When we have big sets, then we can use this method. Otherwise, you can use arrow diagram. Hope it is clear to everyone. Now, second type. Second, we will see many one function. Which one? Many one function. So what is many one? See, by listening the name, you can understand that what is the meaning of many one function. Many mapping with one, that's it. Many mapping with one is called many one function. Let's say example I am giving you. Let's say this is set A, okay, and let's say this is set B, okay. So A, B, C and D, okay, just a minute. C and D, and this one is E, F, G, H. These are element of set A and set B. Okay. So I am saying that definition is what? Many mapping with one. Let me write here. Many mapping. Many mapping with one. With one. Okay. Is called what? Is called, you can say that this is many one function. Okay. So see here. You can see here. A mapped with E. Getting this? And B also mapped with E. So many mapping with one. One is what here? E. And E has two images. Means E is image of A and B. Getting my point? E is image of A and B. Okay. And you can also say that C mapped with F and D also mapped with B. So this is what? This is nothing but many one function. Many mapping with one. That's it. Okay, see one example I am telling you. One example. Here you see fx is equals to x square. Okay, and function is defined from real number to real number. Function is defined from real number to real number. So you put any real number. Okay, A set, and this is B set. -2. If you put -2 in the function, then what you will get? You will get only 4. Means 2 mapped with 4. Okay, and if you put +2, then you will also get 4 only. Getting this? If you put 2, x value 2, then you will get 4. X value -2, you will get 4 only, right? Okay. And if you put -3, let me scroll here. If you put -3, then you will get 9 only, right? 9 only. And if you put 3, then you will also get 9 only. So what we can conclude? Many mapping with one, right? So this is many one function. Hope it is clear to everyone. And if you want to take one more example, you can take the fx is equals to mod x, right? And function is defined from a real number to a real number. You can take example. Okay. So now you see again what we will do. Set A and set B. You take -2, put here x value -2, then what you will get? 2 only. Because mod always gives the positive value, right now? So -2 mapped with 2. If you put 2, then definitely positive value. Means mod of -2, you will get positive always, okay? And 2 will get 2. Getting is? Then after, minus 3 if you put, then what you will get? 3 only. 3, if you put the value of x3, then you will get this only, 3 only. So this is how you can explain many one function. Okay. Now third one is onto function. Onto function. Onto function. So what is onto function? Onto function is also called surjective function. One function, injective function, or onto function is called surjective function. Don't get confused here. Okay, surjective function. Surjective. Okay. So see here, a surjective function is a function. A surjective function is a function whose codomain is equal to its range is called surjective function. Means what? See, we will try to understand through the diagram. Okay. Let's say this is set A. In this set, A, B, C, and D. These are the element of set A. Okay. Then after, let's say set B is there, and elements are P, Q, R, S. What I said, my definition is what? Codomain is equal to its range. Let me write here. Codomain is equal to its range. Its range. Okay. So now you see, A mapped with P. Okay. B mapped with Q. C mapped with R, and D mapped with C. Okay. Now you see, set of element A is what? Domain. Set of element B is what? Codomain. What is range? All the elements of set B, which are means mapped element of set B, that is range. So now you can see very clearly that codomain is what? P, Q, R, and S. Right? Codomain is what? P, Q, R, S. And you tell me what is the range? Range is mapped elements. So which all elements are mapped in set B? So you can see that P, Q, R, S. Right? So now you see very clearly, you can see very clearly that codomain is equals to range. Getting it? Codomain is equals to range. Codomain is also PQRS and range is also PQRS. So we can say that this is onto function and surjective function you can also say. Clear? One more example I am taking. See, set A and set B. Okay. So this is A, B, C, D, and E, and G, H, I. Okay. So now you see A mapped with G, B also mapped with G, C mapped with H, D mapped with H, okay, and E mapped with what? I. E mapped with I. So now you see, and now you tell me that codomain is equals to range. So you can just check. So this is the domain. This is what? Set of all the element of A is what? Domain. So you can write here domain. Domain. And set of all the element of B is what? Codomain. So let me write here. Codomain. Codomain is what? G, H, I. Right? Only 3 elements are there. So this is what? Codomain. And what is the range? Range, what I said? Mapped element in set B. So now you can see which all elements are mapped in set B. So G, H, and I. So what we can say? G, H, I. These are what? Range. Now you see very clearly. Now you can see very clearly that codomain GHI and range is also GHI. So can we say that this is onto function? Yes, absolutely. You can say that this is onto function. Getting this? Clear? Okay. Now again, if we have a small set, but like this, you can represent and you can tell this is onto function and surjective function. If we have big sets, means natural number to natural number, real number to real number, in that case, how we can prove, how we can show that this is onto function? So let's see here. Few steps are there. Okay, few steps are there. First First step is what? Fx is equals to y. Fx is equals to y. Means one function will be given, okay? That will be in the terms of what? X. Means fx is equals to, let's say, x cube plus 7. So we have to assume y is equals to x cube plus 7. Like this. When we solve the question, then you will get to know. Okay. Second step is what? Solve. Second step is what? Solve to find. Solve. Solve. Next step you have to solve. Okay. Means to find the value. To find the value of x. Getting this? Second step means you have to solve this equation and you have to find the value of x. Getting this? Means x you will get in the terms of y. Means x is equals to whatever you will get, that will be in the terms of y. Hope everyone is getting it. And third point is that having found the value of x, you have to check that x is defined for all the values or not, for the all values of y or not. Okay, so third point is what? Check if x is defined, if x is defined for all values or not. Okay, getting it? Means once you find the value of x, then you have to check. You have to check that x is defined for all the values or not. If it is defined, then you can say that this is onto function, and if it is not defined, then we cannot say that this is onto function. So let us one example we will do. Then after our concept will be cleared. Okay. So let's say one example. Fx is equals to x cube plus 7. X cube plus 7. Okay, and function is defined from real number to real number. Fx is equals to x cube plus 7 and function is defined from real number to real number. Means what? Domain is real number, and codomain is also real number, right? It's a big set right now. So what we will do? First step is fx is equals to y. Then it's okay, no problem. So y is equals to what? X cube plus 7. Y is equals to x cube plus 7. We just follow the steps. We have to follow the steps. Whichever steps are there, okay, we have to follow. So first fx is equals to y. So what I have done, function is given x cube plus 7. So I have assumed it what? Y is equals to x cube plus 7. After that, it is saying that to find the value of x. So it's okay, you have to find the value of x. So what we will do? Y minus 7 is equals to x cube. Okay. So what we can write? X is equals to y minus 7 to power 1 by 3. You know it very well, right? If x power n is equal to, let's say, y, then x is equals to y to the power 1 by n. Okay. Getting it? Now, second step is clear. Third step you see very clearly. Check if x is defined for all the values or not. Okay, now you have to check. Now you see. You tell me x is defined for all the value of y. Means what? If you put real number, if you put real number here, if you put real number here, then can you get real number? Yeah, definitely you can get real number. Whatever value you put of y, okay, whatever value, even though if you put negative value, you will get real number, right? Because cube roots of negative number is possible, right? You understand that cube root of minus 8, so you will get minus 2 right now. So it is possible. So yes, what we can say? Yes, x is defined for all r, right? All r means what? Real number. So what is real? So y. So if you put y value, whatever real number you put, so x is being defined here. Okay, so you can say that yes, it is what? Onto function. What we can say? It is onto function. Is it clear? Okay, if it is not clear, if you did not get, so okay, it's okay. I am taking one more example. See here, fx is equals to 1 by x minus 1. Fx is equals to 1 by x minus 1. And again, function is defined from real number to real number. Getting it? Function is defined from real number to real number. So what is our the first duty? Y is equals to function. So y is equals to 1 by x minus 1 I have written. Okay. Then after, you have to get the value of what? You have to get the value of x. So that what we will do? So we can write x minus 1 is equals to 1 by y. Okay. So what we can write? 1 by y plus 1. Simple equation is there. Then after x is equals to 1 plus y by y. Okay. So now finally we have got x is equals to 1 plus y divided by y. Now you have to check that x is defined for all the values of y or not. If it is defined, you can say this is onto function. If it is not defined, then you cannot say. Getting it? So okay. So let's check. If you find its domain, then what we are seeing? You can see very clearly that if you put y is equals to 0, then function is being undefined here, right? So x is not defined for all the real values. Getting it? Means 0, if you put y is equals to 0, getting this? If you put y is equals to 0, then what will happen? X will be undefined, right? If it is undefined, then we cannot say that this is what? This is onto function. Hope it is clear right now. So what we can say? What we can say? It is not onto function. It is not an onto function. Clear? Why it is not an onto function? Because you see, x is not defined for all the values of y. X is not defined. You can write here. X is not defined. X is not defined for all the real values of y. 0 is real number, no? So if you put, then function is undefined. So we cannot. Okay. So hope it is clear to everyone. And one more type is there, that is into function. That is into function. So what is into function? Into function. See, into function, a function whose codomain is not equal to its range. Understood? Function, a function whose codomain is not equal to its range. That is called into function. Getting it? So see here, codomain is not equals to range. Let me write here, codomain is not equal to its range. Its range. Okay. So now you see, let us say set A is there, A, B and C, and let's say set B is there, what? D, E, F, G and H. Okay, these are the elements in set B. Okay, and A mapped with D, A mapped with D, then after B mapped with E and C mapped with F, C mapped with F. Now you tell me, is it into function? Yes, absolutely it is into function. Why? Because you can see that domain, domain is ABC, first element of set A, right? So let me write here, domain is what? A, B, C. This is the domain. Okay. Then codomain. What is codomain? Codomain, you can see all the element of set B. All the element of set B. So which all elements are there in set B? D, E, F, G, H. These are the element in domain, means in set B. Okay. Then after range, you see range. Range is what? Only mapped element in set B. So which all elements are mapped? D, E and F. So you see here D, E and F. D, E, F. Now you can see very clearly, that codomain is not equals to range, because codomain is D, E, F, G, H and range is only mapped element which are D, E, F, right? So finally we can write here that codomain is not equals to range, right? So this is what? This is into function. This is what? Into function. Understood? See, it is just, reverse of onto function. Onto function, what was that? Codomain should be equal to its range, right? But into function is what? Codomain should not be equal to its range. Understood? Getting this? Okay. So one example we will see here. By that, our concept will be cleared a little more. So let's say fx is equals to 2x. fx is equals to 2x, and function is here defined from natural number to natural number. Okay, natural number to natural number. So now you tell me that this is into function or not. See here, this is what? Domain. This is domain, and this is what? Codomain. This is codomain. So let us say, see here, set A, set A, 1, 2, 3, 4. These are the element of set A, and set B. You see here very clearly. Many students get confused in this thing actually. Okay, so you see very clearly, and B. B is what actually? B is codomain. Getting this? Codomain. So codomain what? Codomain is natural number. Codomain is natural number. But I am going to write what? I am going to write 2, 4, 6, 8. Why? Because see here, natural number 1. If you put 1 here, then what you will get? 2. If you put 2, you will get 4. If you put 3, 3 to the 6. If you put 4, 4 to the 8. Getting this? Getting it? Okay. Now you see here, you can just map A mapped with 2, 2 mapped with 4, 3 mapped with 6, and 4 mapped with 8. Okay. So now you tell me, what is here range? First we'll discuss range. What is range here? Range you can see 2, 4, 6, 8. 2, 4, 6, 8. Getting this? 2, 4, 6, 8. What is domain? What is domain here? Domain is natural number, means 1, 2, 3, and 1, 2, 3, 4. Yes, 1, 2, 3, 4. Okay, means these numbers are given in the natural numbers. Okay, then after you tell what is codomain. What is codomain? Codomain actually generally we say that element of set B is codomain, but condition you have to also consider. It is not that we will not consider the condition, which is function is defined from natural number to natural number, that we have to consider. So you can see here, codomain is natural number. Codomain is natural number means what? 1, 2, 3, 4 dot 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 dot. Right? So what we can conclude? We can conclude is that range is 2, 4, 6, and codomain is 1, 2, 3, 4. Right? So can we say that this is what we can say into function? Can we say? Can we say? Yes, we can say that this is an into function. Why? Because range and codomain is not equal. Range is 2, 4, 6, 8, and codomain is natural number 1, 2, 3, 4 dot 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 dot. Right? So we can say that this is what we can say that it is an into function. Into function. Is it onto function? Is it onto function? No, this is not onto function. Why? Because codomain is not equals to range. Hope it is clear to everyone. Okay. So thank you everyone. Thanks a lot.